the which one is that? The ticket sales. Okay. Oh, I went 2, 3. I wrote that to you. 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 We're done. All right. So we do that quickly because we got a lot to do. No offense. So in these ones here, you will see this throughout a few of the examples today, guys. A lot of the examples that we run through today. One of the things that I want you guys to get accustomed to doing, and we did this throughout the day yesterday about plotting your x and your y values first. But then what I want to do is look where I'm going to have some of my extra intercepts and whatnot. So, yes, sir. Oh, now if I go through this one, if I look at my last equation is where most people screw up. The reason why most people screw up is because they have to solve for your S. Cover and solve. What's 3,000 divided by 0.5? 6,000. Be honest. I bet you at least 4 or 5 of you guys wrote 15. And then you go back and you realize, like, oh, that doesn't work. It's one of those silly mistakes that happens. Be careful with that. So I know that I'm going to have an S-intercept at 6,000. Okay? That gives me a G-intercept by cover and solve at 3,000. Inward or outward? Moving inward. Okay? These next two graphs are either horizontal or vertical, depending upon the variable. The G equation is on the vertical axis, which means it's going to be your y values. I have an intercept at 2,000. Which means, as you are horizontal, your y value never changes. Yes, sir? It doesn't. Just be careful when you label it. You don't accidentally flip-flop it when you're substituting your profit thing. Your graph will just look like sideways, and it's okay. Now, that means the y value stays constant left and right. So this ordered pair here will be something 2,000. Okay with that? Now, if I look at that is the role of G. Half of what plus 2,000 is 3,000. Well, move it over, that means half of what is 1,000? 2,000. So that ordered pair is at 2,000, 2,000. Okay, so far? All right. Do the 4,000 as the vertical. I think it was more this way. Which means the x value now is 4,000. What's the y value? Okay, but in our terms, the x value is being played by the s. So half of 4,000 is how much? 2,000. 2,000 plus what is 3,000? 2,000. That gives me my ordered pairs. This one was at 4,000. So we're in there. Okay? Yes, sir? My S value is 4,000. Half of 4,000 is how much? 2,000 plus 1 is 3,000. I am substituting into that other equation. I'm still using systems of equations. I'm still using the systems of equations, but these are the easy ones because you know that it is 2,000. It is 4,000. Okay? And then from there you go through your profit stuff. Okay? Let's look at the tape player one. Tape player. Yeah, 4. I just wanted to help make sure you guys can see this through, okay? Tape player 1. They manufacture radios and tape players. They have the capacity to manufacture at most 600 radios, 500 tape players. They cost the company $10 to make a radio, $12 to make a tape player. They can spend up to $8,400 in building those products, and they make a profit of 19 and 12 maximize profits, how many of each should they make? Well, what's your objective? Money. Again, in this case, our objective is to maximize profit. So we have a C equals, well, how much profit do you make on a radio? How much do you make on a tape? 12. So I'll say 19R plus 12T for radios and tape players. Which means, what am I going to put on my x-axis? R. The reason that I'm doing that is because it's my first variable. So when I list out my ordered pairs, I know to put the R value into the 19. Okay? It says you want to manufacture at most 600 radios. Are you going to make more than 600? Make less than 600. Yeah. So your radios are going to be less than or equal to 600. What about tape players? Less than equal to 500. Very good. And then the only other part in here, they talk about how much it costs to build them. How much does it cost to make a radio? And tape players. So I have 10 for the radio plus 12 for the tape deck. And I have up to and including how much money to spend? $8,400. Very good. Okay, so far so good? All right. Suggestion. At this point, you know that you were going to have horizontal and vertical lines, 600, 500. That's not a big deal. But before I place those in there, I'm going to place the one that's going to have intercepts further out. Because I can tell right away that I'm going to have an R intercept of 840. Do you see that? I know that. I'm thinking ahead of myself a little bit sometimes with these. And I know that I have an R intercept of 840 and 0. And then I'll have if I cover this up, a T intercept at, what is that, 700? Inward or outward? Inward, very good. You're moving inward. Excuse me. I have a vertical line at what? Very good. I have a horizontal line at where? 500. Vertical line 600, which means this X value for that is going to be 600. And then I have a horizontal line at 500, which means this will be at something, comma, 500. They're both moving in. Assuming. All right. 10 times 600 is how much? 6,000. All right. So that means that 12T is going to be, what is that? 2,400. What's T? Well, I'm sorry. What is the value? Thanks. In this case, if I solve for T, what do I get? 200. All right, so it'll be 200. So 600, 200 for that one. Okay. I do the same thing. 10 times the radios plus, well, 500 times 12 is 6,000. So what's the R? Be 240 then, okay? What we're doing is we're using direct substitution in order to figure out where you're crossing that diagonal line, the one that has the slope, okay? That's how most of these problems work out, especially when they're talking about you have parameters that are less than, they're greater than, a single variable, as opposed to where you have two of them, where you have to do your linear equation where you're covering and solving, okay? From there, it's just cost analysis and going. All right. Did you flip-flop the order pairs again there, or were you the same way I did? Like I said, it's not wrong to go the other direction. It's just got to be careful. It's so easy to flip them and not realize you did it. Excuse me. Now, from what I felt and what I was talking with first hour, they flew through this. Okay? And it was like, oh, okay, cool, sweet. That was fun. Maybe not. So there's that. And so what we're going to do is I've got a couple more, and I'm going to show you guys how to set up one that's a little bit weirder. I got more. So this is the one that had the. I think I sent it to you yesterday, where it's got a 1 and a 2 on both sides. One says Betty, and then a snack bar, and then the other side is filing cabinets and football and soccer. Cool. Yes, sir. Sorry. Actually, was Shimke took it, and he handed it to me first. And he said, you know what, let's teach her a lesson. You can put your name on the cover, but someone can take the bottom. It's Shimke. I mean, it's Shimke. Let's blame Shimke. Okay, let's look at the one about Betty. Good old Betty. Betty is. Oh, I thought I had this out. Let's look at the Betty problem. So, Betty, good old Betty is out there working extra hours. Betty is working a maximum of 20 hours a week, programming computers, and tutoring English. All right. She makes $15 an hour for programming and $10 an hour for tutoring. She wishes to work between 3 and 8 hours per week programming, but always wants to give more time to tutoring. To maximize the amount she earns, how many hours should she work at each job? This is worded a little bit differently than the ones that we've done before. Okay? But, once again, what's her objective? Maximize profit. So, Betty still wants to make some money, and she knows that she makes how much for programming and how much for tutoring. All right, so we'll do 15 for programming. We'll use P, and then what do you think we should use for tutoring? I was going to use a U, but yeah, we'll use T. Joking. Okay. Joke, levity, take a deep breath. It's okay. I know, it's going to be all right. So that means when I go to get ready to graph, I'm going to put my P for X, T for Y. For those of you guys that were doing that first, was that helpful? So that we know where your order pairs were going? Good, good. All right, so now we have, how many hours a week does she have to work with? 20. So that means that she has programming plus tutoring has to be less than or equal to 20. I don't know if any of you guys have ever taken a computer programming class. You had to take, what, C++ or Fortran or something like that? Oh, by the way, I'm sorry, this is Mr. Dino or Dino? Dino. He's a pre-service teacher over at NIU. He's doing his clinical 301s, which is basically he's showing up here to make sure he really wants to be here. If any of you guys know anybody that's gone into teaching, you have to go through X amount of observational hours. He'll get up in front of us and teach a couple of lessons here and there. He's going to be around helping out in Flex. He'll be also working with the Start Tutoring on Tuesdays and Thursdays. So basically, first semester, he'll be here basically every Tuesday and Thursday. So feel free to ask him questions and stuff like that. And when he's teaching something, heckle. And you're really close. You back up some, then yes. You just backed up a little bit. Nice. All right, anyway, so back to your programming. If any of you guys ever take a programming class, you will realize that it sucks. Computer programming is awful. That's why you only want to work between 3 and 8 hours of it. Okay? You want to do less of that. Yes. Okay. Now the next one is a little bit deep, a little bit weird. It says that she wished, but always give more time to tutoring. How would you write that? What's that? See, tutoring has to be greater than programming. Okay. Now, I know that the wording in here doesn't say that it just says more than. What I want you guys to remember is that most of the problems that basically all the problems that we're talking about, when we're doing linear programming via the word problem, treat everything like a less than or equal to or greater than or equal to. Okay. We got through this yesterday. We shouldn't have to do this every day. Okay? This is the weird one that we haven't seen yet. So I wanted to make sure to show you guys how this stuff gets plotted. According to this diagram, yes, sir? I know, and that's what I was getting at, because we wanted to actually find the true intercept. If it was just a greater than, it can get infinitely closer, like I'm not touching you, I'm not touching you, I'm not touching you. But yet, we want to know those intersections. That's why you have to take a little bit of greatest. What are going to be my largest intercepts? 20s. See how the 20s are going to be on my ends? Bless you. All right? I'm going to put 20s on my ends. Are we moving inward or outward? Moving inward, okay? We know it's got to be moving inward. Okay? Now, I have that 3 and the 8. Are the 3 and the 8 going to be verticals, or are they going to be horizontals? They're going to be verticals because my value of p is along the x-axis. That means those two have to be vertical through the 3's and the 8. So I just kind of place it. See, here's 3, here's 8. Okay? I know that it has to be between those two values, so it's going to be in that pipeline, if you will, somewhere in this region now. You all right with that? Now, those verticals are treated like an x value. That x value stays constant throughout the vertical line, which means that the intersection here, the ordered pair is going to be 3, comma, something. Well, think about what line that ran into. It ran into basically x plus y is 20. Well, x is 3 plus y. There you go. Direct substitution. Same exact thing with the 8. The 8 stays constant going vertically. So if it stays constant and it gets the x plus y is 20, 8 plus y is 20. All right. Now we have one last one to worry about. T is greater than or equal to P. Now this one's going to be kind of weird. I want you to think of this as y equals x. If you think about it in terms of y equals x, what's the slope? It's 1, because it still is. Okay? Now, think about where that line is going to intersect x plus y is 20. Where's it going to intersect that line if y equals x? 10, isn't it? See, what you're getting at here is you're learning about how to place the next line. If you think about where it's going to go, since these two have to be equal, if I'm substituting into where it's going to run into it, that means those two values have to be the same. So even though it doesn't look like it's a perfectly slope of 1 because of the scale that you're drawing, you know that this intersection point has to be where x and y are equal because that's what this line is. Which means that this ordered pair has to be at 10, 10. Are we okay with that? It's a little weird to think about, but it takes a minute or so to figure. Yes, sir? What do you mean? For... No, it's not crazy. I was just wondering where it's going. It was like y equals 2x. Okay. Yeah. They need to substitute different numbers. Okay. I mean, the process doesn't change. Okay. The process won't change on that. Okay. Now look at where your graphs are. This one's moving into here, into here, into here, which means I have to get this point here. What's that vertical spot there? 8, which means what's the y value? 8. Okay. And then my last one is here at 3 and 3. See how that works too? See how that works itself through? What's weird about these when you have where it says you want to spend more time doing one thing versus the other, you try to plot everything else out as you can first, and then look at where things are going to get situated. As you know where you wind up with these ordered pairs here, here, and here, and that's 8 and 12. And you know that's the intersection at this point with that. Knowing that the next step is y equals x, p equals t in this instance. What plus what's 20 when the two what's are the same? 10 and 10. Okay. That's where you start to mess around with the graphs, and it just takes a minute to look at. We hadn't done one like that. I just wanted to make sure I showed it. Okay. Substitution-wise, now it's easy. Right? The rest of that part's simple. Take a minute and look at the next one is the snack bar. Take a minute and try to get the snack bar setups. All right, take a minute and get the snack bar. For argument's sake, I'm looking at snack bars and things, and those are really good questions. Question about your cost. Do you have to write it as 0.21, 0.33, or can you say 21 and 33? It's perfectly fine if you write it as 21 and 33, but just remember your answer is then in terms of cents. So like I was saying, you could wind up with 783 cents. Means 783 cents, whatever. But it doesn't matter. So I would have done, we know that we made hamburgers at 0.33 for a burger, plus 0.21 for a hot dog. Okay, now some people use H for hamburgers, D for dogs. It's as long as you are consistent with however you set it up, it's fine. Your labels might be different than mine, but the numerical setups should be the same. Which means I'm going to go like this: burger, hot dog. It says stay in business. You must sell at least 10 hamburgers and but not cook more than 50. Then sell at least 30, but not 70, and can't cook more than a total of 90s. So we have burgers for between 10 and 40. Yeah. The hot dogs are between 30 and 70. Add them together. It has to be. And it's going to look exactly like the ones we set up earlier, where you have your diagonal downs, 2 verticals, 2 horizontals. Obviously, you'll have to play with your scaling. I think I might have messed up with the corner piece here. One of these might be wrong, but for all intents and purposes, it should be something like that. Okay? Now, what I'd like you to do for this evening is finish these out. The other two on the next side, the cabinet problem is really straightforward. Okay? And then the soccer practice one, Looks just like the one we did with Benny. Okay? Now, as we work through these things, my goal is to make sure we have this completely nailed down tomorrow. And then I got 4 more. And then what we're going to do on Thursday then is we're going to do the quiz on just these on Thursday. Okay? Because this portion of where we're at encompasses solving systems, graphing, everything. So I can give you guys 3 word problems and call it a day. That's probably what we'll do. So, and then on Friday, that'll allow us to start very simply the quadratic unit. Don't worry, I'm not going to get you homework on it, but we'll at least start it. Okay? I know it's hopefully weekend. You're not going to do it. I might fight that battle. But that way it'll give us a breather for the Thursday night. Because when I was looking at the rest that's in this chapter, so we have systems of equations that we can do 3x3s. No reason to do that by hand. I can show you how to use a calculator. It's called a matrix. Okay? Questions? All right, go ahead and work. I'll run around. You good, Devin? All right.